This is TMUA 2021, Paper 1, Question 17. The question gives us 5 potential sketches of the graph of sine of x squared plus y squared is equal to half, with x squared plus y squared being less than or equal to 8 pi. We're asked to determine which of those graphs is the correct one. So we want to analyse this equation. So this x squared plus y squared in the bracket looks kind of complicated to solve. So let's just make a substitution. Say z is equal to x squared plus y squared. And we're now trying to solve the equation sine of z is equal to half. I note that z now has to be less than or equal to 8 pi. So let's sketch this curve and we can maybe work out what these solutions are. So this is sine z. And we note that we're looking for z equals a half. So we have a solution here and a solution here. We also have 2 more solutions there. And in fact, we have infinite many solutions because sine is periodic. So what is this solution? Well, this is precisely pi over 6. And the other one is 5 pi over 6. So what would be the general solution for this for an infinite range? That's precisely pi over 6 plus an even multiple of pi, or 5 pi over 6 and plus an even multiple of pi. And since z needs to be less than or equal to 8 pi, it also must be bigger than or equal to 0 because x squared plus y squared is non-negative. So that leaves us with only n equals 0, 1, 2 or 3 that work. So we're left with x squared plus y squared is either pi over 6 plus 2 pi, which is 13 pi over 6, and then pi over 6 plus 4 pi, and pi over 6 plus 6 pi. And we can do the same thing for 5 pi over 6, and we get these 8 solutions. So what do these 8 equations mean? Well, for general k, x squared plus y squared equals k is a circle centered at the origin with a radius square root of k. So we have 8 circles. And so what can we do? How might we be able to tell between the 5 graphs that were shown? Well, we notice that all our solutions come in kind of groups. So pi over 6 and 5 pi over 6 come in this pair from this first part of the sine wave, so this one peak. Then you also have 17 pi over 6 and 13 pi over 6 come from this region. So we see that we can group these circles, we can group the circles which have the radius from the same period of sine. And so we should see that our graph should come in pairs of circles. And so which options does that rule out? Well, it rules out options C and option D. So now we're left with A, B and E. And how do these graphs differ? Well, if you look at it, we notice that the difference is in how far apart the pairs go as the radius increases. So for option A, the pairs get closer and closer together as you increase the radius. For B, they stay equidistant, and for E, they get further apart. So which case does our graph lie in? Well, we know that the radius of these curves are literally the square roots of all of these numbers. So our radiuses are square root of pi over 6, square root of 5 pi over 6, all the way up to square root of 41 pi over 6. And for the time being, let's ignore this square root of pi over 6 as every single term is multiplied by it. So we want to know how far apart our pairs are. So we're comparing the distances between each of these radiuses. And so the gap between the first pair and the second pair is the same as the gap between root 13 and root 5. And the gap between the third pair of circles and the last pair of circles is the gap between square root of 29 and the square root of 37. So let's work these out. Square root of 5 is approximately 2, and square root of 13 is approximately 3.5. And similarly, we can approximate these 2 numbers as 5.5 and 6. So we see that the gap between the first pair of circles and the second pair of circles is almost 3 times larger than the gap between the third pair and the fourth pair of circles. So we must be in option A.